this video, we're going to do some computations using waves. And our first one here, a vibrating standard completes 110 cycles every second. What are the period and the frequency? So 110 cycles every second, that's telling us actually the frequency. Frequency represents how many cycles per unit of time. Usually it's going to be in seconds. So our frequency is going to be 110 hertz. Now the period, to compute the period is 1 divided by the frequency. So in this case, we would have 1 over 110. And now when we are computing period, we're figuring out how much time it is. So since our 110 is in hertz, which in this case is cycles per second, our unit is going to end up canceling out, and it's going to be in seconds. So we would have 1 over 110 seconds would be the period for this. Okay, question 2. A child on a swing takes 4.5 seconds to complete one back and forth swing. What are the period and the frequency? So in this case, we know that the time to do one swing, and that is essentially the definition of period. So the period for this one would be 4.5 seconds. Okay, that is going to be our period. Now, in order to find the frequency, we would take 1 divided by the period. So in this case, our frequency is going to be 1 divided by 4.5. And since our unit here was in seconds, this is still going to be hertz. Now, sometimes they might have you change this back into a decimal. If that's the case, you would go ahead and divide those two values out, and this turns out to be 0.2222 repeating. If we look for significant figures, we have 2 significant figures, so we would leave it at 0.22 hertz for that one. Or they might have you leave it as that fraction. It also could be written in a more appropriate form as 10 over 45 hertz. Typically, we don't like to see decimals in a fraction, but we're not too worried about that right now. So any of those 3 answers, I would be fine with. Okay, now question 3, it says, if the child in the above question moves a distance of 6 meters per cycle, what is that child's speed? So in this case, we're going to be using the formula for speed, which is lambda is equal to our frequency times our wavelength. Scratch that V, we're doing speed. Velocity is frequency times our wavelength, which is lambda. So we are trying to find the child's speed. We know the frequency from the question up here in number 2 to be, I'm going to leave it as 1 over 4.5 hertz. We know our wavelength because this tells us it's 6 meters per one cycle. So we know our wavelength is to be 6, and we can multiply those together. And we get V equals 1.3 repeating. Now for our units, our wavelength was in meters, our frequency in hertz, which is like cycles or oscillations per second, but the cycles part isn't actually part of the unit, it's just a count. So you'll notice our label is going to be meters per second for our velocity. And then let's see, it looks like we only get one significant figure, so we would want to put that in as 1 meter per second would be that child's speed. Now, let's say that they give us a different type of a problem here. I didn't have one of these typed up, but let's say it tells us that there's something and it oscillates 80 times in 10 seconds. And it wants to know what the frequency and the period are. You're still going to be using kind of the same idea as the definitions of those. So the frequency is how many times per second. So we would then need to take the 80 times per is equivalent of a division problem. And so we would take it 80 divided by 10, which would then reduce to 8 times or oscillations or whatever they're using as their term per second, which would then be 8 hertz. If it also wanted the period, we would still use the same formula where we would do 1 over the frequency. So that would then give us 1 over 8 seconds per cycle. So that's telling us that one cycle would take 1/8 of a second. Or it can go back and forth 8 times in 1 second. So that might be another version that they might show you some of these questions.